Hello people, what's going on? So today we're going to look at a very particular problem in calculus. So this is something we've seen before, but in a different way, right? So let's look at this. So we're going to find the volume of the solid generated when the area enclosed by the curve y equals x squared and the line y equals x is revolved about the line y equals x. Okay, very important. It's revolved about x, right? The line y equals x, not the x-axis. Many confuse it with the x-axis. So let's just make a quick sketch to see how this looks like, right? So we're going to have the y-axis and the x-axis, right? And we have y equals x and x squared, right? So this over here is the area we want to revolve, right? We want to revolve that area about that line, the same line, right? The area that's enclosed between x squared and y equals x. Now we know that these two functions intersect at two very specific points, right? So when we said both of them equal to each other, so we have x squared equals x. Okay, so we have x times x minus 1 equal to 0. So x equals 0 and x equals 1. They both intersect at 2 points, right? So at x equals 0 and at x equals 1, right? So that's important to keep in mind, right? Now, the height over here is also 0, so like the y value is 1, I'm sorry, it's 1, it's going to be 1, right? So because if you substitute 1 into x squared, you're going to get 1, okay? The same goes for x. Alright, I apologize if there is some background sound because the ACs are on since today is a really hot summer day, right? It's like 97 degrees Fahrenheit outside, so we can't stand that. Alright, so I'm going to go ahead and show you how to derive two expressions, two very important expressions, so that we can find a function, that we could use, to integrate easily, right? Because if you look at this, if we use the disk method, we're going to use the disk method. The radius, the radius has to be perpendicular, to the curve, to whatever function you're revolving, right? So this is going to be the radius r, right? And it's going to change from here to here. So it will depend on that function, But in this case, it's perpendicular to the axis y equals x, right? So it's no longer perpendicular to x or y, right? Or any other parallel axis, right? So that's a big issue, big issue, right? So what we could do is we could use our imagination, right? And we could bring this down. We're going to bring this entire thing down. We're going to rotate it negative 45 degrees down. So we're going to bring all of this negative 45 degrees. And why? Well, because if we look at the triangle that this makes, so from here to here, it's going to go like that. The distance from here to here is 1, and from here to here is 1. So this is an isosceles right triangle, right? We know that both of these angles have to be 45 degrees. So in order for the line y equals x to match with the x-axis, we have to rotate it negative 45 degrees down, right? And this over here, this distance has to be 1 times the square root of 2. Okay, we know that already. Now, how are we going to rotate it? Very good question. Well, suppose you have another parallel, plane, right? So let's suppose that you have another Cartesian plane, right, with an x and a y axis, right? And we're going to have a point, an arbitrary point on the plane, P, with coordinates x, y, right? And that point, has a distance from the origin, has a distance from the origin, a distance from the origin of d. Let's call it distance d, right? Now, we're going to, redraw, the line y equals x over here. So this is going to be the line y equals x, But since we're going to match it with the x-axis, we're going to call it the x prime axis, right? So this is going to be the new axis when we look at it later. And so if we have an x prime axis, we also have to have a y prime axis, so it's going to be like that, right? This is the y prime axis. So it's basically rotating the entire plane, the entire Cartesian plane 45 degrees down, right? But we're just going to generalize this, okay, into a formula that we can use to rotate it about any angle. It doesn't matter if it's 45, 30, 35, any angle theta, right? So let's say that we're going to rotate this down negative 45 degrees, right? Or we're just going to generalize it, right? So that's going to be just theta, right? And this over here is going to be an angle of alpha. So the distance makes this line segment makes this an angle of alpha with the x prime axis. Nice. Now let's look at the lines perpendicular, okay, to both of these axes, and that connect to the point P, right? So let's make two perpendicular lines with the x prime axis and x axis. Okay, so we're going to make two perpendicular lines, and the purpose of this is so we can make two right triangles, right? If you can see, this is one and this is the other triangle, right? Now we're going to define the x, the y, the x prime, and the y prime coordinates, okay, using theta, alpha, and d. But eventually, okay, ultimately, we're going to have something in terms of x, y, and theta, and that's it. That's all we want, right? Because we already know that, right? So let's take a look at this. Now, if we look at the right triangle, okay, the larger triangle, the one that goes all the way to the x-axis, we can find these two distances, the x distance and the y distance. So we know that the coordinates of these points are x, so this is the distance of x, okay, from here to here, and this is the distance of y, right? So let's find that in terms of theta, okay, and d. So we know that this over here, so x is equal to d times, okay, if we're looking for the x, is going to be cosine of theta plus alpha, okay? Now y will be equal to d times sine of theta plus alpha, okay? Now let's do the same thing for the x prime, y prime plane, right? So we're going to look at the x prime, y prime plane, and we're going to look at the y prime distance, right, and the x prime distance. So right over here, we're only going to use the angle alpha, right? We're no longer worrying about the angle theta. So we're going to do x prime is equal to, okay, d times the cosine of alpha, and y prime is equal to d times sine of alpha. We're going to use some trig identities over here to expand that. So we're going to have x is equal to d times cosine theta, cosine alpha, minus sine theta, sine alpha. Okay, and we have y is equal to d times sine of theta times cosine of alpha plus sine of alpha times cosine of theta. Two identities. Then we can distribute the d on both terms, right, for both equations. And we notice something. The x prime can be substituted for this over here. So d cosine alpha, d sine alpha on both equations, right? So we're going to have something like this. X is equal to d cosine alpha is just x prime, right? We know that already. So it's going to be x prime times cosine of theta, right over here, minus, okay, d times sine alpha is y prime, right? So that's going to be y prime times sine of theta, right? And we're going to do the same thing for y. So y is equal to, okay, x prime, right, d cosine alpha, x prime sine theta, plus y prime cosine theta. But remember, we want to solve in terms of x, y, and theta. So all we have to do is isolate x prime and y prime. Okay, we're going to have that in terms of x, y, and theta, because that's what we know. Okay, we know the function y is equal to f of x, right? We know that f of x is equal to x squared. Now what we want to do is we want to find the new function, but that we would rotate this whole thing. We're going to have something new, something like this, right? So we're going to have the x squared curve turn like that, and this is the x prime, y prime plane, right? This is this plane over here, the new Cartesian plane that we came up with, right? The one that we're rotating. So this over here is going to be a new function. We don't know what that function is. That depends on these two equations over here, but that's going to be y prime is equal to f of x prime. Okay, so when we know f of x prime is x prime squared, so it's going to be y prime is equal to, okay, x prime squared. So we have to find what y prime and x prime are equal to in terms of x, y, and theta. So I'm going to go ahead and erase this over here since we don't need it anymore. Okay, I prefer to stay on the same side of the board because flipping the board around is annoying, so I'm just going to go ahead and erase what we already know, and I'll leave that down over there. So we're going to solve that system of equations over here. Okay, so we're solving for x prime and y prime. So how about we isolate that? So x prime is equal to y x plus y prime sine theta. Okay, everything divided by cosine theta. And we also have y prime. Okay, y prime. Let's just write it over here. Y prime. Okay, over here in the second equation is equal to y minus x prime sine theta. All of that divided by cosine theta. Okay, we can substitute each of them, okay, simultaneously. So we can do x prime is equal to, okay, x plus y prime is this entire expression over here. So we have, okay, y minus x prime sine theta, all of that over cosine theta, times sine of theta, all of that divided by cosine theta. Okay, that's getting messy. And let's just erase this over here because we already know that in a different configuration over here. So let's just simplify a little bit because I don't like how that looks. So let's do x prime is equal to, okay, x over cosine theta is x secant theta plus y over cosine squared theta times sine theta. So that's going to be y sine of theta times secant squared theta, okay, minus sine squared divided by cosine squared is tangent. So we have minus x prime times tangent squared theta. Okay, now over here we have an x prime and another x prime, so we could bring it together and then factor it out, right? So we can factor out x prime and we're left with 1 plus tangent squared theta is equal to x secant theta plus y sine of theta secant squared theta. 1 plus tangent squared theta is one of the trigonometric identities, so, and that's going to be equal to secant squared of theta, right? So this over here is secant squared of theta. We can divide that on both sides, right? So we have x prime is equal to x secant theta divided by secant squared theta is x over secant theta, and x over secant theta is just x cosine theta. So we have x cosine theta. Okay, we're going to divide that, everything divided by secant squared theta, right? So 1 power, and then we have plus y. Secant squared theta cancels out, so we're left with y sine theta. Good. Now we're going to do the same thing with y prime to find out what it is. So let's erase all of these over here. We're going to add x prime squared up. So let's see. Now y prime is equal to y minus x prime, right? So this entire expression over here, we're going to substitute it up there. So we're going to have y prime, y minus, okay, x cosine theta plus y sine theta, that times sine theta, and everything divided by cosine theta. Okay, now we can simplify this a little bit because it's messy, right? So we have y secant of theta, so y prime is equal to y secant of theta minus x cosine theta over cosine theta times sine theta. See, this two cancel out, so we're left with x sine theta minus, okay, sine squared over cosine theta. So we're going to have minus y sine squared theta secant theta. We have two y's over here, two secants. We can factor that out, so we have y prime is equal to y secant theta times 1 minus sine squared theta minus x sine theta. 1 minus sine squared theta, okay, that's going to be cosine of theta, right? So that's going to be cosine squared of theta, right? So secant theta over cosine squared theta, okay, is going to be, what's that going to be? No, cosine squared theta over cosine theta is going to be cosine theta, so it's going to be something like that. Okay, cosine squared theta, because that's what we're left over with over here, right? So cosine y cosine theta divided by cosine theta, that cancels out, and we're left with that x and theta. And so our final answer is y prime is equal to y cosine theta minus x and theta. So these two are the very important functions, the very important formulas we're going to use to find y prime equals x prime squared, so we can integrate this function a lot more easily, because we know that the radius over here is perpendicular to the x prime axis. So that makes our life a lot easier, right? So let's go ahead and erase this over here. Okay, so we can make more space, because going to the other side of the board will make things harder. I'll forget what this is, so it's better to look at it. Alright, so y prime is equal to x prime squared. This over here is very important. We're gonna substitute these two expressions into this function, right? Into this equation. So let's go ahead and substitute y prime over here. So that's going to be y cosine of theta minus x sine theta is equal to x prime squared. X prime is that, right? So x cosine theta plus y sine theta, and all of that has to be squared. Okay, so we have y prime equals x prime squared. So now we can simplify a little bit. Now we can already evaluate cosine of theta and sine of theta. We know that theta is negative 45 degrees because we're going clockwise, right? If we were to go counterclockwise, it would be positive 45 degrees. But in this case, it's not. So theta is negative 45 degrees, right? And cosine of negative 45 degrees is just cosine of 45 degrees, because cosine is an even function, right? So that's going to be root 2 over 2. And sine of negative 45 degrees is just sine of negative sine of 45 degrees, because it's an odd function. So that's going to be negative root 2 over 2, okay? And we can just substitute those two values in this equation. Okay, so y times root 2 over 2 times y, right? So minus, okay, negative times negative is positive, so 1 plus root 2 over 2 x equal root 2 over 2 x plus root 2, I'm sorry, minus because it's sine theta, minus root 2 over 2 y. All of that squared. Okay, so we don't need this anymore. Okay, so let's go ahead and simplify this. For now, what we could do to make things easier, and then we can substitute at the end. We can let root 2 over 2 equal to some letter, right? Just to make it easier for now. So let's say that root 2 over 2, okay, is equal to alpha. Just for now, right? In the end, we're going to substitute alpha back in. So let's go ahead, okay, and substitute that in there. So alpha y plus alpha x is equal to, okay, alpha x minus alpha y squared. Now this over here, we have to solve for y is equal to f of x, right? Because we want to integrate f of x, okay? We want to integrate f of x squared times pi from 0, okay, to whatever value this is over here. And we know that that's going to be root 2, right, times root 2. Yeah, because we already found that the distance of the hypotenuse of this triangle is root 2, right? It's an isosceles right triangle. So this is root 2, so it's going to be from 0 to root 2 on the x prime y prime plane, right? So 0 to root 2 of f of x squared dx. We have to integrate that in that way. So we have to have something that says y is equal to f of x. So y is equal to x something, right? I don't know what it is. So we're going to solve over here. And the problem is we have two y's, right? We have y on one side and y on the other side. And this over here is inside the squared, right? So that's going to make things a little harder, but we will see how we can go about solving it. So let's go ahead and distribute this. We're going to FOIL that. So alpha y plus alpha x is equal to, okay, alpha squared x squared minus 2 alpha squared xy plus alpha squared y squared. Okay? Now here's the trick. We're going to bring everything to one side. So all of this over here, we're going to bring it to the other side, right? So we're going to have something equals 0, right? So we're going to have all of this. Let's put the y squared in first, right? You're going to see y. So alpha squared y squared, right? Minus 2 alpha squared x y, right? Minus alpha times y, okay, minus alpha x plus alpha squared x squared equal 0. All of that equals to 0. Now, why did I highlight the y's, okay, in the equation? Because we're solving for y, right? And what does this look like if you were to ignore x and alpha and everything else, right? So just imagine everything else is a constant, right? This precisely looks like, okay, ladies and gentlemen, this precisely looks like a quadratic function. It is a quadratic function, in fact. It's just in a different configuration. It's not like the regular quadratics we see in high school, right? So we're going to use the quadratic formula to find y is equal to f of x. So let's go ahead and we recall that the quadratic formula says, okay, so we want to solve for y. That's going to be equal to negative b. Okay, in this case b, okay, it's in here. So we have to factor a y term over here. So we have b is going to be, so let me just rewrite all of this in here, just with the b in it, right? So let me do it on the bottom so I can erase that on the top. So alpha y squared minus, okay, and we're going to factor out a positive y, right, times 2, okay, we're going to have 2, negative 2, alpha squared x minus alpha, okay, that's going to be our b, right, minus, or let's do plus, you know, that negative alpha x plus alpha squared x squared. Good. And all of that equals to 0. Now this over here is our a, this is our b, and this is our c. So we're going to use the quadratic formula to find y equals f of x, right? So let's erase this over here. It's a very non-trivial problem, right? So let's go ahead. Okay, it's not what you expected, right? Very innocent looking. So let's go ahead and use the quadratic formula. So we have y is equal to negative b, so negative of that. So everything becomes positive, right? So 2 alpha squared x minus alpha, okay, oh, plus alpha, right? Because everything becomes positive. Plus or minus, right? Very important. Plus or minus the square root of b squared. So it's going to be, this squared is the same as the positive of it squared, right? Because we have negative 1 factored out. And then we have negative 2 alpha squared x plus alpha, and all of that squared, minus 4 times ac. A is alpha. Oh, I'm sorry, this is supposed to be alpha squared, yeah, because we squared that time out. So this is alpha squared. And so this is 4a times c, 4ac, and c is all of that over there. So let me just put it over here, times negative alpha x plus alpha squared x squared. All of that under the radical sign, and everything has to be divided by 2 times a, so 2 alpha squared. Alright, now let's go ahead and substitute alpha in so we can make some simplifications, right? So we know alpha is root 2 over 2. And if we square it, since we see a lot of squares, right? So alpha squared is root 2 squared over 4, so it's going to be 2 over 4, which is just 1/2. Okay, so we can go ahead and substitute this into the equation. Y equals 2 times alpha squared is 1/2, so 2 times 1/2 of x, plus alpha is root 2 over 2, okay, plus or minus the square root. Negative 1 squared is just 1, right, so that doesn't matter. And here 2 times alpha squared, so it's going to be 2 times 1 half x plus root 2 over 2, all of that squared, and we're going to have over here, we're going to have minus, okay, 4 times, okay, minus 4 times alpha squared, which is 1 half, and we have times negative alpha, right, so all of that, negative alpha, so negative root 2 over 2 times x plus 1 half x squared. And all of that divided by 2 times 1 half, so which is just 1, right? So we don't have to divide by anything. Good, makes things easier. Now, let's go ahead and simplify something. So you see 2 over 2 is 1. Okay, 2 over 2 is 1. Good. So here, 4 over 2 is 2. So that goes to 2. And I think we have to FOIL this, right? So we're going to go ahead and FOIL that. So let's rewrite this. Y equals x plus the square root of 2 over 2 plus or minus the square root, okay? We have x plus square root of 2 over 2 squared. So we're going to FOIL it, right? So we have x squared plus 2 times ab, which is 2. Okay, so it's actually radical 2x plus 1 half. Okay, we're going to have minus 2 times that. So negative negative is positive, so we're going to have plus radical 2x. Right, because we have this 2 cancels out with this, negative with negative is positive, and we're left with root 2x. Minus, negative times positive is negative, so minus, and then 2 over 2 is 1, so minus x squared. Good, looking good now. Oh, look at this, x squared and x squared, okay, cancels out. Root 2x plus root 2x is 2 root 2x. Okay, so let's go ahead and we can find the common denominator of that. So we have 2 root 2x, right? So 2 root 2x plus 1 half. We could find the common denominator by multiplying this by 2 over 2. So we're going to have 4 root 2x plus 1, all of that divided by 2. But that's under the radical sign still, right? Very well. So this is the function, okay, that we're looking for. This is y equals f of x. But the problem is, since we're doing the quadratic formula, we have a plus and a minus. So we have to choose which sign is going to be correct. In order to do that algebraically, because I could show you on a graphing calculator, I'm going to do that later, but now, is by testing a point that we know is going to be true for our problem. And only for our problem, right? So over here, let's look back at this. So we know that this point over here in the x prime, y prime plane is going to be root 2, 0, right? We know that that's going to be part of the integration. So how about we just substitute that point? Okay, we're going to substitute that point into this equation to see if it's true. Now I'm thinking, if you want y to be equal to 0, right? So we're going to have 0. So let me just erase the bottom part. So if you want y to be 0, and then you have equals to root 2 plus root 2 over 2, and then you have a square root over here, 4 times root 2 times root 2 again, right, plus 1, all of that over 2. If you want that to be equal to 0, will you add it or will you subtract it? Because regardless, anything under the radical sign has to be positive, otherwise it will be imaginary, right? So how about we just test the negative? So let's go ahead and test it. So we have 0 is equal to root 2 over 2, okay, plus root 2, right? So we could find common denominator for this, and we have 3 root 2 over 2, okay, minus the square root of 4 times root 2 times root 2, which is just 8. 8 plus 1 is 9, so we have 9 over 2. So the square root of 9 is 3, right? And we're left with 0 is equal to, okay, 3 radical 2 over 2 minus 3 over radical 2. And we know 1 over radical 2 is just root 2 over 2. So we have this. And look at that. That cancels out, so we're left with 0 equals 0. So that means that point is true for this function when it is negative, right? So we're going to forget about the positive. And finally, we finally found our function y equals f of x, right? The one function we're going to integrate next, okay, that's going to be interesting. So let's go ahead and okay, classify this. So I'm going to circle this. This is very important. This is the function. This is this function, in fact. This is over here. Okay, this is the negative part. Okay, because there is a positive part, of course, and it's going to go like that, right? But we don't care about that. We're only integrating this side, right? So let's go ahead and erase this, right? We don't need it anymore. And we're going to move on to the calculus world, finally. So, remember that in order to use the disk method, right, we need to have a radius perpendicular to the axis we're rotating about. We already achieved that, okay, using the transformation of planes, right, the rotation of curves. So, over here, all we can do, okay, is integrate from 0 to root 2 using the area of a circle, right? Because think about cutting a slice. So imagine that this over here is going to be the solid. It kind of looks like a football if you think about it, right? It's going to look like a football. But if you cut a slice of it, right? If you cut a slice of it in half or somewhere in there, you're going to get something, right? Like that. And it's going to have an area of pi times the function squared, okay, and the radius is f of x, right, the function, the value of the function. So, knowing that, when we cut a slice from that solid, it is a circle, right, knowing that it is a circle, we can add up all the circles, okay, from this point to this point. Okay, so we're going to go ahead and add the areas, okay, so we're going to do volume of revolution is equal to, okay, pi times the radius squared from 0 to root 2. So pi times the integral from 0 to radical 2 of f of x squared. So this is f of x over here. This is the one f of x we're looking for. So we're going to put f of x over here. So x plus root 2 over 2 minus the square root of 4 radical 2 plus 1 divided by 2. All of that squared dx. Okay? This is going to be the volume of revolution. You can go ahead and put it in the calculator, but I'm going to go ahead and try it, okay? I'm going to try evaluating it without a calculator first. So let's go ahead. We don't need this anymore. Let's go ahead and evaluate this integral expression. So first of all, let's just split it up into, okay, easier parts, okay, smaller parts so we could solve it, right? Calculus is all about splitting up problems into smaller parts so we could solve it easily. So let's say that this is going to be our A, and over here, this is going to be B, right? Because we're going to square that. If I just square, you know, all of this, it's going to take me a while, right? Because it has 3 terms, it's a triangle, right? So what we're going to do now is we're going to FOIL this, right? This is A plus negative of that, right? So A plus B. So we're going to square that. So the volume of revolution, right? Volume of revolution is equal to pi times the integral from 0 to radical 2 of a squared. So it's going to be x squared plus 2 times ab. So plus root 2x plus 1/2 a squared, okay, plus 2ab. So plus 2 times that x plus root 2 over 2 times b. So b is negative the square root of 4 radical 2 plus 1 divided by 2. And then we're going to add b squared. So b squared is just 4 radical 2 plus 1 over 2 because the radical cancels out when you square that. And we have the x at the end, okay? Now as you can see, you can already integrate these few terms, the first few terms, because it's very trivial to integrate that, right? So let's go ahead. I think I forgot something over here. Wait a minute. Yeah, this has to be multiplied by x. Yeah. 4 radical 2x. 4 radical 2x. Yeah. That has to be multiplied by x. Okay, good. It's important not to forget. Alright, now let's integrate the first terms that we think are easy to integrate. So let's go ahead. We can integrate this, and this over here. We're going to leave this to the end, right? That's the more complicated part. Alright, so the volume of revolution, okay, is equal to pi times x squared over 2, okay, plus root 2 x, I mean this is x cubed, yeah, x cubed over 3, root 2 x squared over 2, plus 1/2 x, okay, and then we're going to integrate this as well, right? So this is actually two terms. So we're going to have plus, okay, 4 over 2 is 2, so we're going to have 2 radical 2, x squared over 2, that 2 cancels out, plus 1/2, right? So 1/2 x. Very good. And we're going to have, oh, everything has to be multiplied by pi. I forgot the pi. Excuse me. So we have pi, another pi over here, and pi. Okay, because that has to be distributed, right? And then we have plus pi times the integral from 0 to radical 2 of, okay, the last part. So that's going to be 2x plus radical 2 times negative the square root of 4 radical 2 x plus 1, all that divided by 2 dx. Okay, so I'm going to go ahead and erase this side over here because we're running out of space. Let's just erase all of that. So we're going to evaluate that last term and then substitute our values, upper and lower bounds. So let's go ahead and try to integrate these over here. So something we could do, let's see, what could we do? We could multiply, okay, we could distribute this, right? So how about we try to distribute that to make it easy? So we have volume of revolution, right? We're going to do this part only for now. So volume of revolution partially, right? So we're going to do partially is equal to pi times the integral from 0 to root 2 of 2x, negative 2x, times the square root of 4 radical 2x plus 1 over 2. Okay, and then we're going to have plus pi times the integral from 0 to radical 2 of radical 2 times radical 4 radical 2x plus 1 divided by 2 dx. Okay, dx. Good. Now, over here we can bring that 2 inside the radical, right? And we see that that cancels out with that, so this radical 2 cancels out. Over here we have negative 2 times x radical of that. So maybe we could use the substitution, a u substitution for both of them, right? Because we know that it's only 1 degree, first degree x, right? So we have x to the 1 over here, and an x outside. So first let's do this over here. We have, okay, let's bring that over here. So that's going to be pi times the integral from 0 to radical 2. And let u, okay, equal to this under the radical. So let u equal to 4 radical 2 x plus 1. So du will be 4 radical 2 dx, right? So we substitute by dx. dx is du over 4 radical 2, right? So that's going to be the square root of u, right, times du over 4 radical 2. We can bring that constant outside. Okay, so we have pi times the integral from 0 to radical 2. Okay, let's just make that division. We're just doing these two things first. So pi times the integral from 0 to radical 2, right, of all divided by 4 radical 2, right, of radical u du. Now we know how to integrate u to the power of 1/2, so that's going to give us, okay, but this is, the upper and lower bounds are still with respect to x, so we haven't changed, okay, the upper and lower bounds. We're just going to go back to x later. So pi over 4 radical 2 times u to the 3/2 times 2/3, right? Okay, and then we're going to substitute u back in. So we have pi times u, which is going to be 4 radical 2x plus 1, all of that divided by 4 radical 2, and then times 2 over 3. Now this cancels out, this simplifies to 2, and we're left with pi times 4 radical 2x plus 1 divided by 6. Okay, so that's one part. That's one part. And we're doing the last part over here. So let me erase this for you to see. We could get to some place. Alright, let's do this part now. We got this, okay, and we got this over here, right? So far we got that. Okay, so let's go ahead and substitute this over here. So here we have to do the same thing. We're gonna let u equal to 4 radical 2 times x plus 1, so that du is 4 radical 2 dx, and of course dx is du over 4 radical 2, and we can substitute that in there. But we also have to find what x equals to in terms of u, so we're just going to minus 1, so u minus 1 over 4 radical 2 is equal to x. So we have to substitute that in there too. Okay, so I'm going to have to erase this as well because we don't have space. Okay, so alright, we're going to substitute that in there. So we have pi times the integral from 0 to radical 2, okay, times, well, let's bring the negative 2 outside. So let's bring the negative 2. Okay, negative 2 pi times the integral from 0 to radical 2 times x. We know x in terms of u is u minus 1 over 4 radical 2, okay, times the square root of u, right? Oh, but here the thing is, we didn't cancel out the 2, right? So that's going to be u, the square root of u, over 2. Okay, that doesn't matter. We still have, okay, u. So and that's going to be du. We're going to substitute the x by du over 4 radical 2. Okay, u substitution. Alright, now we can see that these two are the same, so we can square that and bring it outside, and we can distribute this radical u over 2 on these two terms. So we're going to go ahead and bring that to the outside. So we're going to have negative 2 pi over 16 times 2, right? Integral from 0 to radical 2, and then we have u to the 1/2 times u to the 1, so which is going to be u to the 3/2, right? 1 plus 1/2. So, and that's going to be minus u to the 1/2. Yeah, all of that divided by 2, by radical 2. Okay, du. Oh, we could also bring the radical 2 outside, right? So we have that times radical 2. Okay, good. Now we can integrate this easily. So we have, but let's simplify this over here. So 2 cancels out, and we're left with negative pi over 16 times radical 2. So we got negative pi over 16 radical 2, integral from 0 to radical 2. Well, let's just evaluate the integral already. So we have, okay, the integral of u to the 3/2 is u to the 5/2, right? Divided by 5 over 2, which is just 2 times 2 over 5, right? Minus the integral of 1/2, which is 2/3 u to the 3/2. Okay, so we already found all the pieces of this puzzle. We're going to bring all of that together. Whatever is circled with in black, right? We're going to bring it together, and we're going to substitute the u that we got over here. So let me just erase this over here, so we have more space. Okay. So okay, so let's just get more space out. Okay. So let's bring everything together. Alright? So we have pi x cubed over 3, right? Plus pi root 2 x squared over 2 plus pi over 2 x, okay? Plus pi root 2 x squared plus pi over 2 x, okay? So look at that. That's 2 pi over 2x. So we can already add that together, and we get only 1 pi over pi x, right? So we get pi x. And we can also add this together, but that's going to give us something else, right? So that's going to be pi root 2 over 2 x squared plus pi root 2 over 1 x squared. Okay, that's going to be equal to, So that's going to be equal to 3 halves, right? So 3 halves pi root 2 x squared. Okay. And then we have k pi x, and then we have these two answers over here. So we have plus pi times 4 radical 2 x plus 1 divided by 6, right? So pi over 6, and then we have minus pi over 16 root 2, okay, times, and then we said that u was this over here, so that's going to be times 2/5 of 4 radical 2x plus 1 to the power of 5 halves, okay, minus, or we could do minus, so that doesn't matter. So we do minus 2/3 4 radical 2x, okay, plus 1 to the power of 3 halves. And now that evaluated from 0 to radical 2. Okay, so this problem turned out not to be so trivial afterwards, right? So let's go ahead and, okay, find the value, okay, of the volume of revolution, if we can, without a calculator, right? So let's go. So we're going to go to Desmos to see if we could evaluate this integral, okay, the integral of volume of revolution from the not so trivial problem. Okay, so we have that the volume of revolution is going to be pi, okay, times the integral. So we're going to go to functions, miscellaneous. We're going to take the integral from 0 to radical 2, okay, of x, okay, it's going to be x plus root 2 over 2 minus, okay, we're going to do minus the square root of 4 times radical 2 times x plus 1, okay, and all of that divided by 2, right? So we're going to divide that by 2, and we're going to square everything. So we're going to square all of this, so squared, and then dx, okay. Alright, so we have that the value, okay, the value of that integral, ladies and gentlemen, is 0.074 cubed units, okay, 0.074 cube units. So that's the value of the integral. Okay, so if we want to, if you want to see how the function rotates using the transformation formula, so we can go ahead and plug that in here. So cosine of a, y cosine of a, okay, and then we have minus, okay, minus x sine of a, all of that is equal to, okay, remember that this is y, right? So this is y prime. Now we're going to put x prime squared, so that's going to be equal to y sine of a, okay, plus x cosine of a, alright, and then all of that has to be squared, so that's squared, and we're gonna add, okay, some limitations, so that's going to go from negative, okay, from negative 180, let's just put it to 0, okay, or to 180, yeah, that's right. Not 1800, okay, 180. So let's see if we could rotate this curve 45 degrees, right? So all we could do is we could change the slider to negative 45 degrees, right? So let's go change it up to negative 45. So as you can see, the curve over here is rotated negative 45 degrees. Oh, but this over here is wrong, so let me see what's happening. Oh, I know what's going on. So we have to change these to degrees. There you go. Okay, that makes more sense. Alright, so right over here, okay, is the x prime y prime plane, right? And from 0 to radical 2, we can integrate it, right? We can integrate this function. So just like on the first line over here. So that's going to give us that, alright? And it's going to be 0.074 cubed units. 0.074 units. Okay, so that's how you find the volumes of revolution about any axis. Okay, if you have never seen it before, just give it a like, okay? Subscribe to my channel. And thanks for watching. So I'll see you next time.